Okay, welcome to the Aspire Academy. I am Siddharth. So today I am going to represent one new topic. This is called mechanical properties of solid. So what is mechanical properties of solid? Before starting the mechanical properties of solid, the one new concept is called, first of all, what is deforming force. So first of all, the one is called deforming force. So what is deforming force? First of all, so what is deforming force? If we apply some force, we have already know that what is force. Force is the mass product of mass into acceleration. So force. So what is the deforming force? If we apply a force in an object or anything, it can deform. The size and shape can be deformed. That force will be called as deforming force. So after deforming force, another one is called elasticity. Elasticity. So what is elasticity? First of all, we know already elastic property. So what is called elastic property? So elastic property, rubber and other rubber like things are called, it shows some very good elasticity. So what is elasticity? Suppose if we apply a deforming force in an object, it will deform, and after removal of this deforming force, this automatically it regain its original shape and size. So this is called elasticity. So another one word is called perfectly elastic body. Perfectly elastic body. Perfectly elastic body. So what is perfectly elastic body? So first of all, we know the deforming force. What is deforming force? If we apply a force, this force, it can be deformed as solid thing, or it can solid thing. It can deform by shape and size. This force is all we are termed as what? Deforming force. Okay, so this deforming force has applied on an object that can deform, and after that, what is elasticity? If we apply a deforming force, the body, it can change its shape and size, and after removal of this deforming force, this body regain its original shape and size. This is called elasticity. And after that, another new term we can include it here. So what is called perfectly elastic body? So what is perfectly elastic body? If we apply deforming force in an object or in a body, it can change its shape and size, or it can change the dimension. After removal of deforming force, it is immediately it can regain its original shape and size. It's called perfectly elastic body. Okay, another one term is called plasticity. Plasticity. So what is plasticity? So plasticity is one kind of thing. The plasticity means is a plastic body. Suppose in our day-to-day life, if we apply a force in a plastic body, then what will it can broken, or it can change its shape and size. If we remove the deforming force, it can, or if it regain its original shape and size? No. So if we apply a deforming force in a body, it can change its shape and size, but after the removal of deforming force, it cannot regain its original shape and size. This is called plasticity. These are the terms. This first term is called what? Deforming force, elasticity, perfectly elastic body, and plasticity. These are the main terms we are using here in this chapter, mechanical properties of solids. So very, very important thing. What is called deforming force, what is called plasticity, what is called elasticity, and what is called perfectly elastic body. So these are the new term associated with this topic. So after that, another one main term is called stress. So what is stress? Stress is, we can apply, what is stress? Stress is equal to applied force by area. So if we applied a force in an object in a particular unit area, this is called stress. We also know that pressure is also force by area. and stress is also we can term as what? Force by area. Both are same, but one difference will be there. If we what is the pressure and stress? These are what? The SI unit of stress is same as the pressure. SI unit of pressure is stress is what? Force by area. We can call as force is the Newton, area is a meter square. So Newton per meter square is termed as what? SI unit of what? Stress. Same Newton per meter square is the same as the pressure. So what is the basic difference between stress and pressure? If we apply some pressure in an object, it cannot be deformed. It can be change its shape and size. If we apply stress in a body, it can change its shape and size. So this is the difference between pressure and stress. So this is a very, very important topic for this topic. So in this topic, so this is called stress. Stress means what? Applied force per unit area. So this is called stress or force by area. So its unit is called Newton per meter square. Okay. So this is stress. Another one topic term is called strain. What is called strain? Strain. So what is strain? Strain, suppose if we consider suppose wire or any box, anything else. Suppose if we apply force, what will happen? It can change its shape and size. If it is suppose 1 meter wire is there, if we apply force here, then it can elongate it with a 2 millimeter elongation. Means shape, size and length will be increases by 2 millimeter. This 2 millimeter divided by this original dimension is called this ratio is called strain. So now, strain we can define as like that: change in dimension to the original dimension. Change in dimension to the original dimension. This is the main formula in every aspect. So strain is equal to what? Change in dimension to the original dimension. Now we are given one example here. Suppose this is a wire, okay? If we apply some wire as length is suppose L, if we apply some weight here, so this much of length will be increases. So if we apply weight here, mg weight, this much of length will be increases. This length we can consider as del L. This how we can represent this strain? Strain is equal to what? In this case, strain is equal to what? Del L by L. Means change in dimension to the original dimension is called as strain. This is in case of the length respect. If we change this topic, so if we change the volume, same it can be strain will be possible. So change in dimension to the original dimension is the strain. So strain is there three types of strain. Strain is there three types of. One is called longitudinal strain. Number two is called volumetric strain. And number three is called shear strain. So there are three types of strain is there. One is called longitudinal strain, okay, and another one is called volumetric strain, and third one is called shear strain. So these are the different types of strain. So strain, we have already discussed that strain is the change in dimension to the original dimension. So now what is longitudinal strain? Longitudinal strain means what? Change in length to the original length. Change in, okay, first of all, what is longitudinal strain? So what is longitudinal strain? We have already discussed strain means change in dimension to the original dimension. What is longitudinal? Change in length to the original length. Change in length to the original length. Suppose we have a one length where is like that. So this is the length is L. Suppose if we apply weight here, this much of length will be increases. This is called del L. So if we apply a force here, this amount of force, and this is the what? This much original change in length means was in this longitudinal strain. How we can represent these things? So change in length means was this mass of change del L. Original length how much? Original length L. So longitudinal strain means what? Change in length to the original length is called del L by L. This is the formula for longitudinal strain. So next one is called volumetric strain. So next number 2 is called volumetric strain. So what is volumetric strain? Volumetric strain is what? Same change in volume, same change in volume to the original volume. Change in volume to the original volume. How we can represent? Suppose this is a one cube. Suppose this one is a cube has volume V. Suppose if we apply stress here, what happens? The volume will be changes to what? Del V. So now volumetric strain we can change in volume. How much? Del V, original V, V. So change in volume to the original volume is called volumetric strain. So another one, the next term is called as shear strain. So what is shear strain? Shear strain. So what is shear strain? So if we apply, suppose this is a block has lower base one is fixed. If we fix this lower one, then if we apply a force here, what will happen? This, if we apply force here, then what will happen? Lower base one is fixed, then it will bend like that. It can be bend. So what will happen? How much it can be bend? Theta amount of bend. So theta is the whole what? It is called shear strain, or shear strain is called, this is called support how much of length is bent? Del L, and related displacement is called L. This del L by L is called as shear strain. Okay, now 3 types of strain we are getting. So what? First of all, longitudinal strain. Longitudinal strain we can represent LS means what? Del L by L. Volumetric strain, how we can represent? Del V by V. And similarly, shear strain we can call as theta is equal to what? Del L by L. So these are the different types of strain we are getting. So this is very, very important for your exam point of view. So 3 strain, longitudinal strain, volumetric strain, and shear strain. So next one, next topic is a very, very important. So this is called Hooke's law. What is Hooke's law? So first of all, we know that strain, what is strain and what is stress? Strain is stress. Stress means applied force divided by area. So stress. So another one, strain means what? Change in dimension to the original dimension. According to the Hooke's law, within the elastic limit, stress is directly proportional to the strain. So within the elastic limit, so how we can represent the Hooke's law? Within the elastic limit, stress is directly proportional to strain. Within the elastic limit, the stress is directly proportional to strain. So this is called Hooke's law. So now how we can represent this in mathematical way? How we can represent this in mathematical way? mathematically stress is proportional, this is proportional sign, strain is directly proportional to strain, so stress is equal to one constant term we are getting. So what constant? This is called constant into what? Strain. So what is, how we can represent this Hooke's law? Hooke's law means stress is directly proportional to strain. What is the meaning of directly proportional? If stress is increasing, automatically strain also increasing. So this is the meaning of directly proportional. So stress is directly proportional to strain. So how we can represent in mathematically way? So stress is equal to one constant we are getting, constant into strain. This constant is called coefficient of elasticity. This constant is called coefficient of elasticity, or it is called modulus of elasticity. Of elasticity. This is very, very important. So this is what is called coefficient of elasticity or modulus of elasticity. Better we know that modulus of elasticity is a perfect term to express this Hooke's law. So what is the constant? This constant we can call as modulus of elasticity. So now this modulus of elasticity we can call as, so now constant is equal to what? Now constant is equal to what? This is the constant, then stress divided by strain. This constant is called modulus of elasticity, and this modulus of elasticity is called as stress by strain. So modulus of, now we can call as modulus of elasticity is equal to what? Stress by strain. So this is the important representation of Hooke's law. So Hooke's law, what is Hooke's law? First of all, within the elastic limits, stress is directly proportional to strain. So stress is proportional to strain. Stress is equal to constant in strain. This constant is called as what? Modulus of elasticity, and this constant term stress by strain, and this constant we can represent as modulus of elasticity. Okay. So next topic. So there are three types of coefficient of elasticity and modulus of elasticity. So there is this constant we can term three terms in respect of shape and size. So modulus of elasticity. So there are three types of modulus of elasticity. Number one is called Young's modulus of elasticity. Young's modulus of elasticity we can term as capital letter Y. Number one. Second one, bulk modulus of elasticity. This is called kappa, small letter k we can represent. And number three is called modulus of rigidity. Modulus of rigidity, or we can term as shear modulus. Shear modulus we can call as eta. This is called as eta. There are three types of modulus of elasticity. One is called Young's modulus of elasticity. Y we can term as Y, capital Y. Next one is called bulk modulus of elasticity. Is called kappa. This is called kappa. And third one is called modulus of rigidity, and shear modulus is called eta. The three terms, one is called Y, kappa and eta. So these are three modulus of elasticity in terms of this mechanical properties of solids. So now one by one we can how these three modulus of elasticity can be explained. So in mathematically we can represent like that. So first modulus of elasticity is called what? Young's modulus of elasticity. So first of all, what is Young's modulus of elasticity? This is a constant term. So what is a constant term? This constant term we can represent how we can represent this thing. So Young's modulus of elasticity means it is in case of length. In case of length. So we know that what is the modulus of elasticity? That's stress by strain. So in Young's modulus of elasticity, it is a ratio between longitudinal stress divided by longitudinal strain. So now Young's modulus of elasticity, y we can represent as longitudinal stress divided by longitudinal strain. So this is called Young's modulus of elasticity. So if we consider a wire, there is a wire, we consider a wire like that of length L, the wire of length L. If we apply a force here, suppose force means if we apply weight here, so what will happen? This will be increasing in its length. This is the weight here. So mg, this is the increase in length. This is called del L. So how we can represent this Young's modulus of elasticity? So first of all, stress is same. Stress is what? Force by area. This force by area. Y is equal to what? Longitudinal stress is called force by area. So what is the longitudinal strain? Del L by L. We already discussed that. Longitudinal strain is equal to what? Del L by L. So now here place del L by L. So now Y is equal to what? F by A L into del L. So this is the formula for what? Young's modulus of elasticity. This Young's modulus of elasticity we can represent another way. So Y is equal to, we can represent F is the force here applied here. Force is equal to, we can write mg, yes, mgl. Area is the what? This is the cross sectional area here of the wire. We can represent as cross sectional, represent pi r square into del L. So this is another form of Young's modulus of elasticity. So now to three types of modulus of elasticity you are getting. So one, Young's modulus of elasticity, bulk modulus of elasticity, and shear modulus of elasticity. So this Young's modulus of elasticity is what? It is a ratio between longitudinal stress to the longitudinal strain. We know longitudinal stress is equal to what? Force by area, and longitudinal strain is equal to what? Del L by A. After simplification, Y is equal to what? F L into A into del L. So what is A here? A is the cross sectional area of the wire. What is the cross sectional area of the wire is called pi r square. So what amount of force we applied here? This amount of what amount of force? Force is equal to what? Mg. So mgl by pi r square into del L is equal to what? This is the mathematical expression of Young's modulus of elasticity. Okay. So next topic is called bulk modulus of elasticity. Next point is called number 2, bulk modulus of elasticity. So what is bulk modulus of elasticity? Kappa K. So similarly, kappa is equal to what? Bulk modulus of elasticity is in volume change. So what is volume? We already know that suppose this is a cube here. This is a cube. If we apply force, what will happen? It can be compressed. If we apply here force, and volume can be compressed with what amount? This is the amount of force we apply, the volume is compressed. So original volume is equal to what? V, and change in volume is equal to what? Small v, del V. So what is this? Bulk modulus of elasticity means what? What is bulk modulus of elasticity? Kappa is equal to volumetric stress divided by volumetric strain. We have already know that volumetric strain is equal to what? Stress is equal to force by area, and strain is equal to what? Del V by V. But here one negative sign we can introduce here. So why it is negative sign? Because if we increasing the force in a cube, it decreasing the volume. That's why one is increasing, another one decreasing. That's why we are using negative sign. So kappa is equal to what? Negative of F by A V del V, or kappa is equal to minus P. We know force by area is equal to pressure, PV by del V. This is the mathematical expression for what? Bulk modulus of elasticity. So bulk modulus of elasticity is very, very important. So now how we can represent this bulk modulus of elasticity? So bulk modulus of elasticity is what? It is a ratio of volumetric stress to the volumetric strain. So we know stress is equal to, we already know that, force by area. And what is volumetric strain? Volumetric strain means del V by V. We have already discussed in this way. So volume, if we have increasing the force here, decreasing the volume. So if one increasing and another decreasing, that's why negative sign is introduced here. So kappa is equal to what? Stress by strain. Stress is equal to what? Force by area. Strain is equal to what? Del V by V. After simplification, kappa is equal to minus FV by A into del V, and F by A is equal to what? Pressure. Pressure into volume divided by del V is called as what? Bulk modulus of elasticity. This is very, very important. So second topic, bulk modulus, is over. So next, shear modulus of elasticity. Third one is called shear modulus of elasticity. Third one is called shear modulus of elasticity. Similarly, same shear modulus of elasticity we can represent as eta, Greek letter eta. So eta is equal to what? Shear stress divided by tangential stress divided by shear strain. So eta we can represent what? Stress is equal to already is force by area, or shear strain we can call as theta. How? We can already express this shear stress. If we want, we can consider one block here, and base one is one fixed. If the base one is fixed, if we apply force in the parallel force introduced in the block, what happened? This side is bent. This, how much it bent? This theta will be bent. So that's why theta is called as shear strain, or theta we can call as del L by L, or we can, theta is equal to what? F by A divided by del L by L, or F into L del L into A. So this is the what? Mathematical expression for shear modulus of elasticity. So shear modulus of elasticity is same thing. So what is modulus of elasticity? Stress by strain. So here shear strain of modulus of elasticity means tangential stress, tangential stress, volumetric stress, longitudinal stress is same. So stress is what? Force by area, and strain is different for different structures. So here in case of longitudinal stress, shear modulus, we can represent shear modulus is called what? Eta. Eta is equal to force by area divided by theta. We know that shear strain is equal to theta here. Theta we know del L by L. After that we getting what? Eta is equal to F into L divided by del L into A. So eta is equal to what? F into L del L into A. So this is the mathematical expression for what? Shear modulus of elasticity. Okay. So another one, try one numerical problem regarding this stress strain. Suppose a length question, the length of a suspended wire increases by 10 to the power minus 4 of its original length when stress of 10 to the power 7 Newton per meter square is applied on it. Calculate the Young's modulus of the material of the wire. So this is a numerical, the one basic numerical one. The length of the wire suspended by wire increases by 10 to the power minus 4 of its original length when the stress is what? 10 to the power 7 Newton per meter square is applied on it. Calculate the Young's modulus of the material of the wire. So here, what is the given things? So first of all, we have to calculate what? Means 10 to the power minus 7 minus 4 increases by 10 to the power minus 4 means del L by L, given del L by L is equal to what? 10 to the power minus 4. Del L by Del is a 10 to the power minus 4. Now it's given stress is equal to, we automatically given this 10 to the power minus 10 to the power 7 Newton per meter square. So 10 to the power 7 Newton per meter square is what? Newton per meter square is a unit of SI unit of stress. That's why we know that stress is equal to 10 to the power minus 7, 10 to the power 7 Newton per meter square. We have to calculate what? Young's modulus of elasticity, Y. We know that Y is equal to what? Stress by longitudinal stress by longitudinal strain. Okay, so Y is equal to what? Longitudinal stress is equal to what? Stress is equal to what? 10 to the power 7 here. So 10 to the power 7 strain is equal to 10 to the power minus 4. After calculation, 10 to the power what? 11 what? Newton per meter square. This is a one example regarding the Young's modulus of elasticity. So this is what in today's class. Thank you.